Mr. Clown here from Clare Maths. Today we're going to look at the 2022 National 5 Applications of Mathematics, Paper 1. Let's jump right in. Okay, question 1 was about Stephen blowing up his tyres, and you're given this diagram. And in order to be safe, the tyres should be blown up to a pressure between 35 and 45 psi. It blew them up to 230 kPa. Is this at a safe pressure? So let's find 230 on this diagram. Well, that's here. So lining that up to here is where it is on PSI, and that's 31, 2, 3. 33 PSI. It has to be between 35 and 45. No. He blew them up to 33 PSI, which is below the minimum safe pressure of 35 PSI. Done. Question 2. Mary and John are both reading the same book, and they're using an e-book reader, and John is reading a hard book. John thinks he's read more book than Mary. Is he correct? So Mary has read 62%. John has read 210 out of 350. So let's look at John. To start with, we've got 210 out of 350, which as a percent, I can times that by 100. So if I can somehow play with this fraction and get it into percent easily enough without using decimals, we should be good to go. So let's first of all knock off some zeros to get 1 over 35 times 100. And you should be able to see that 5 goes into 100 20 times, and 5 goes into 35 7 times. But then 7 goes into 21 3 times. So I can divide by 7 to get 3 and divide by 7 to get 1. So we've just got 3 times 20 left, which is 60%. No, John has read less than Marie, as 60% is less than 62%. Question 3. The temperature in degrees Celsius of a restaurant fridge is recorded each day, and the temperatures of the 13-period day were these temperatures. For the data, calculate a median, lower and upper quartiles. So we might as well put the data in order first. So let's look for the smallest number, 2.9 as I see. After 2.9, we have got 3.2, I think. And we've got another 3.2. And then we've got a 3.2 again. Then a 3.3. Then another 3.3. Then I see a 3.4. And then two 3.6s. 3.7. 4.1 and 4.2. 4.2 again, actually. So there's our data in order from smallest to biggest. So we need to find the middle. The easiest way to find the middle is just to kind of come in top to bottom. So if I just make little marks, knocking off the top and the bottom. There we are. You should see our middle number here. That's our median. So then we want to find the middle of the left and the middle of the right for our quartiles. So we've got 1, 2, 3, 4, 5, 6. So it's going to occur here. So quartile 1 is 3.2. And we've got 1, 2, 3, 4, 5, 6. So it's going to occur here. So quartile 3 is between 3.7 and 4.1. So let me just add them up. That gives me 7.8. Divide that by 2. 3.9. So our median is 3.4. Our lower quartile is 3.2. And our upper quartile is 3.9. And what we're in degrees Celsius each time. Okay. Part B. Construct a box plot for this set of data, and this grid is on page 16. Right, so our lowest number is 2.9. So that's going to be here. I'll label that 2.9. Our highest number is 4.2, which is here. So we've got our lower and a higher limit. Our lower quartile is 3.2, which we know is here. Our upper quartile is 3.9, which will be in the middle with 3.8 and 4. So that'll be here. And our median is at 3.4, which is there. Box goes around the quartiles. There's our median. Quartile 1, quartile 3, median, and we connect this up. And there we go, there's our box plot. Calculate the interquartile range. Q3 minus Q1. So we've got 3.9 minus 3.2. The temperature of a cafe fridge was also recorded for the same 13-period day. The interquartile range of these temperatures was 0.9 degrees Celsius. Make one valid comment. So we got an interquartile range of 0.7. Theirs is 0.9, which is higher. So the cafe fridge G's temperatures were less consistent. As 0.9 degrees is bigger than 0.7 degrees Celsius. Okay, question 4. Kieran and Dylan designing their garden, and you've got all these tasks. The first thing we have to do is C and F. C is 6 hours, F is 2 hours. Okay, after C and F, well, where C and F is the last one before it is this one, so that's G, and that takes 45 minutes. Where G is the next one, so where it's here, paint the fence is 3 hours. And then you've got I, rough cast the wall, 1 hour 45. And then after I, we've got A, lay the patio, and E, lay the grass. Well, E's already done for us, so I, 5 hours, A, lay the patio. And after A, we've got B, 1 hour 30, and or H, 2 hours 15. Okay. Based on the times given, calculate the minimum time to complete all the work. Give your answer in hours and minutes. So we're looking for a critical path. So we've got 6 plus 45 min plus 3 hours plus 1 hour 45 min plus 5 hours plus 2 hours 15 min. 17 hours I've got. And then for the minutes, 1 hour 45. So that's 18 hours, 45 minutes. Question 5. Jade runs a game store at Christmas coffee morning. Her game requires 2 spinners to be spun, and these are the spinners. The answers are multiplied together. To win a prize, you have to get an answer of greater than 30. Calculate the probability of winning the prize. So I just need to list all the possibilities. So down one side, we've got 2 up to 6. And the other side, we've got 0 up to 12, even numbers. We're multiplying all these results together. So we've got 0, 4, 8, 12, 16, 20, 24. 0, 3 2s are 6, 12, 18, 24, 30 and 36, 0, 8, 16, 24, 32, 40, 48, 0, 10, 20, 30, 40, 50, 60, 0, 12, 24, 36, 48, 60 and 72. And to win a prize we need a number greater than 30. So we've got this one, we've got this one, this one and this one. We've got this one, this one and this one. And then we've got this one, this one, this one and this one. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 35. 7 times 5 is 35. Question 6. Farah works in a shop, she earns £8.40 an hour. She's paid overtime at time and a half, and Jan short 100 hours plus 30 hours overtime. Then she paid these expenses. What's her net pay? So let's work out our gross pay. That's going to be 100 times £8.40 plus 30 times £8.40 times 1.5. So that's just 840 for this bit. 30 times 1.5 is 45. So if I do 45 times £8.40, so that's 84 times 45 to work it out. 5 4s is 20, 5 8s is 40 and 2. 0, 4 4s is 16, 4 8s is 32, plus 1 is 33. That gives us 0873. So the answer to this bit of the sum is equal to 378. So our total gross pay is 840 plus 378. So that's 8, 8, 9, 10, 11, 12, 12, 18. Now, we then need to take off everything that comes off. So we've got 33.50, 61.92, and 25.20. So that gives us 2, 9, 10, 11, 16, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 12. So our net pay is equal to 1218 minus 120.62. Ten minus 2 is 8, 9 minus 6 is 3, that's 7, that's 9, that's 0, that's 1. So our £1,097.38. Question 7. Tracy decides to walk to the top of Dynamite Hill from Blair Logie Car Park. The horizontal distance between these two places, let's call that Dynamite and that Blair Logie, is 3 kilometres. Blair Logie Car Park is 21 metres above sea level, so let's say that's our C. We know that is 21 metres. And the top of Dynamite Hill is 420 above sea level. So we know that this whole distance here is 420, which means the distance from here to here must be 420 metres minus 21 metres, which is 399 metres. Calculate the average gradient. So the gradient, 399 over 3,000. Don't forget to change that into thousands because it's kilometres and metres. Okay, we can divide by 3 to get 133 over 1,000. Question 8. Brian and Jamie and Jessica bought 2 medium pizzas between them. Brian ate 5/7 of a pizza, Jamie ate 2/3 of a pizza, and Jessica ate the rest. How much did she eat as a fraction in its simplest form, I'd imagine. So to work out how much Brian and Jamie ate, we just add the fractions, 5/7 plus 2/3. Common denominator is 21, just by timesing them together. 5 times 3 is 15, 2 times 7 is 14. That gives me 15/29/21, which is 1 whole pizza with 8/21 left over. Now remember, we had 2 whole pizzas to start with. That means Jessica must have eaten, or 8 out of 21. I need to get 21 out of 21. So 21 out of 21 minus 8 out of 21 to be clear. 21 becomes 11, 12, 13 out of 21s of a pizza. And I suppose you just need to check, can you simplify 13 out of 21? Well, you can't because they're co-prime. So we're done. Question 9. Zainab designs a new badge. The design is based on a rectangle and semicircle as shown in the diagram. She decides to put gold edging around the badge. Calculate the length of gold edging required. So we need to put a bit of the badge. So if I draw a line here, you should be able to see the diameter is 10 and the circumference part is going to be 1/2 times pi times diameter because it's a semicircle. So that is 1/2 times 3.14 times 10. 10 times 3.14 is 31.4, so I just need to halve 31.4. Now you might need to do a little sum at the side to do that, so let me actually do that just in case. Dividing by 2, 2 goes into 3, 1 left over, 2 5s is 10, 1 left over, 2 7s is 14. So the circumference part is 15.7, and then I've got all the straight sides, so the length in total is going to equal 15.7 plus 10 plus, now you need to be careful, from here to here is not 20, it's the whole length, so we know that this bit here must be 5, so it means that this must be 15. So plus 15, and you've got 1 up here as well, so plus another 15. So that's 7, 15, 1, 2, 3, 4, 5, 55.7 centimetres. And that is our final answer. Question 10. A youth group's planning a fundraising night to help pay for a trip. The expenses for the night are shown. They sell 200 tickets. They need to make a profit of 2,000. Calculate the minimum ticket price to achieve this profit. So here's all the expenses. So the total expenses, just add them up, 340, 50, 770 and 40. That's 9, 16, 20, that's 10, 12, that's £1,200. We want to sell 200 tickets and make a profit of 2,000, so that means that we need to do 2,000 plus 1,200. The total amount we need to make is 3,200, so I need to do 3,200 divided by 200 tickets. Knocking the zeros off, 2 goes into 3 once, 2 goes into 12 6 times. Minimum price is £16. A flag is in the shape of an isosceles triangle with a rectangle on top. Calculate the area. Well, you should know the area of a triangle is half the base times the height. So if I cut this here, I need to know the height of my triangle. So we're going to have to use Pythagoras because we know 2 sides. So if we call this x, x squared is 13 squared minus 5 squared. That's 169 minus 25, which is 144. So x must be the square root of 144, which is 12 centimetres. So our triangle area, half the base. The base is 10 times a height of 12. That's 5 times 12, which is 60 square centimetres. And then for the rectangle, that's just length times breadth, 10 times 4, which is 40 square centimetres. So the total area is 100 square centimetres. So a company delivers parcels to people's home. The probability of a parcel being damaged is 0.023. In a month, the company delivered 700, of which 15 were damaged. Is this more or less than expected? Well, let's just check by doing 0.023 times 700. Let's make an equivalent sum. So if we times this number by 100 to get 2.3, we can divide this number by 100 to get 7. And that's quite easy. 7 3s are 21, 7 2s are 14, 15, 16. 16.1 parcels were expected to be damaged. So it was less than expected, as 15 is less than 16.1.